Good afternoon to all. My name is Devakar. Today I am topic discussing about the DA analysis of articulated robots. Introduction to DA analysis of articulated robots. Then I have the Hartenberg analysis is standard mathematical expression used to describe geometric motion and robotic manipulations. It is mainly used for kinematic analysis of articulated robots having multiple links and joints. Articulated robots consist of rigid links connected by rotor by revolute joints, allowing movements in several directions. Basically, we have articulated robots only in rotor joints to move the robots. DS analysis assigns coordinate frames to each link of the robot to describe its position and orientation systems. The methods used for 4 DH parameters. These are the 4 parameters used in DH analysis. First one is link length, which is denoted by A, and link twist alpha, and link offset D, joint angle denoted by theta. Distance between two consecutive axes. And distance is angle between consecutive joint axes. Distance along the joint axis. Joint angle means angle between consecutive links. Articulated robots. Since we discuss about briefly what is meant by articulated robots. An articulated robot is a robotic manipulator made up of multiple rigid links connected by rotary joints. Human arm, like our human arm structure available. Degrees of freedom. Articulated robots commonly have 4 to 6 degrees of freedom. These are the main components of articulated robots. First one is base and link, rotary joints, and actuators or motors, and controllers, end effectors. Each rotary joint provides angular movement, allowing the robot to reach different positions and orientation. Need for DH analysis. Why would we need DH analysis? To similar robot modeling, provide a systematic method to represent complex robotic structures. ఈ analysis మనం యూజ్ చేయడం వల్ల స్ట్రక్చర్ కాంప్లెక్స్ ఉన్న రోబోట్ని ఈజీగా మనం డిజైన్ చేయవచ్చు. To describe link relationships and to determine end effector positions. End effector of a position మనం take చేయొచ్చు. And for forward kinematics converts joints, angles and links dimensions into position and orientation of the end effector. For robot motion analysis, let's understand how each joint movement affects overall robot motion. The analysis use చేసుకొని మనము ఒక రోబోట్ ఒక యాంగిల్ ఎంత మూవ్మెంట్ ఉంటే ఎంత ఎఫెక్ట్ ఓవరాల్ ఎఫిషియన్సీ ఏర్పడుతుందంటే The robot control provides mathematical information required for accurate control of robotics movement. Basic concepts of DH analysis. These are the basic concepts. DH analysis stands for Dynamic Hartenberg analysis. It is standard method used to represent geometric motion and robotic arms. The coordinate frame is assigned to each joint or link of the robot. The relationship between two consecutive coordinate frames is described using 4 DH parameters. These are the parameters we discussed in last time. The parameters will create a homogeneous transformation matrix. The individual transformation matrix are multiplied to determine the position and the orientation of the index. DH analysis procedure. These are the procedure we follow to DH analysis to improve efficiency and numerical of the robot manufacturing. Identify the robot structure. First, we apply the DH analysis to find the these main parameters to improve manufacturing the robot. Identify the robot structure. Sometimes we use structure based to according to working environment, we can design the robot. Identify the links and the joints of the articulated robot. Determine the number of degrees of freedom. Assign a coordinate frame. Assign a coordinate frame to each joint or unit. The Z axis is generally aligned to with the joint axis. Another one is determine DH parameters. Find four parameters of each link. Theta represents joint angle. B equals to link offset. A determines link length and also we have to tissue. Another one is prepare the DH parameters table. Look at the four parameters of every joint systematic table. From transformation matrix, use the DH parameters to create 4 into 4 homogeneous transformation matrix for each joint. Multiply transformation matrix. Combine the individual matrix from the base to the end effector. Determine the end effector, position and the orientation. The final dimension matrix gives the position and orientation of the robotic end effector. Another one is last verify and result. Check the calculated position and orientation with the expected robot configuration. These are the how we calculate the DH analysis for RTL robots. DH parameters we last time we discussed about theta and A and alpha. These are the same kind of coordinating frames. How we DH analysis by identify links and joints, assign coordinate frames, and find the DH parameters, prepare DH table, and create transformation matrix, multiply matrix, and find the end effector position and orientation. These are the advantages we find the DH value. Simple and systematic methods for modeling robots and mechanisms. Reduce mathematical complexity in robots kinematic analysis. Reduce mathematical analysis will be easy to produce more robotics. Use only four parameters to describe easily. Provide a standard way to define coordinate frames and help to determine the position and orientation of the end effector. Useful forward kinematic calculations, support robot motions and static plans, helps in robot simulation and programming, can be applied in multiple links and plans. Robot multiple links and add చేసుకోవచ్చు and useful robot control and automation systems. వీళ్ళలో మనం robot and automation systems వాడుతున్నాం. Disadvantages coordinate frames or assignment can be difficult. And errors in the DH parameters can lead to incorrect and position of the robots. And the method involves mathematical calculations which can be used for beginners. Only skill labors available. And for robots with many joints and transformation matrix, calculations become lengthy. And different DH conventions can sometimes cause confusion in parameter assignment. We mainly focus on kinematic relationship and does not directly consider forces and force. Small errors in these dimensions or joint angles can affect the final result. It may become the less convenient for complex robotic mechanisms with unusual joint arrangement. These are the limitations of DH analysis. Complex frame alignment, parameter errors and length calculation, convention deficiency, kinematic focus, not ideal for every mechanism, sensitive to activity. These are the applications we use in DH analysis to improve efficiency in industries or any other type of industrial robotic design. Industrial robot design building and assembly operations, material handling, painting and coding. Painting sometimes we use, for example, in India, the old green can be required to paint the parts Sometimes that type of operations we use the DA channel to improve efficiency. Machining and pick and place, robot simulation, motion planning and robot control. Conclusion. Unit analysis provides a systematic method for studying the kinematic and later robots. It represents the relationship between links and joints using four-standard parameters. It helps determine the position and the orientation of the interpreters. Transformation matrix simplify mathematical analysis of multiple robots. Image analysis is an important foundation of for forward kinematics, motion planning, simulation, and robot control. It is widely applicable in industry automation and robotics manufacturing. Overall, DH analysis will improve accuracy, understanding, and control of artificial robotic systems. These are the references we include in our PPT. Thank you.